celestial sphere is an imaginary sphere of infinite radius, with the Earth at its center. The extension of the Earth's poles is the celestial poles, namely are celestial pole north and celestial pole south. And the great circle, which is formed by projecting the plane of the Earth's equator, which is everywhere 90 degrees from the celestial poles, is the celestial equator. The great circle of the celestial sphere is inclined at an angle of about 23.5 degrees to the celestial equator, but undergoing a continuous slight change. This angle is called the obliquity of the ecliptic. Ecliptic is a great circle on the celestial sphere, where representing the sun's apparent path. For a comfortable view, and for a better understanding, let us turn it clockwise, apparently making the ecliptic in line with the rational horizon. North Point, East Point, South Point, West Point. Zenith is the point directly overhead of the observer. Nadir is the point directly beneath of the observer. The great circle on the celestial sphere, that is every point of which is 90 degrees from the observer's zenith, is called the rational horizon. The sun set at west and rise at east in a counterclockwise direction is the apparent motion of the sun in the ecliptic. Let us assume that the Earth axis did not tilt. Amplitude is the arc of the horizon between the body and the east-west point of the horizon, is intersected by the observer's prime vertical at 90 degrees. Example. On November 1, 2003, in DR position 36 degrees, 10 minutes, north, 28 degrees, 20 minutes, west, at 06 hours, and 22 minutes LMT, the sun rose bearing 102 degrees, compass. Find the true amplitude and the error of the compass. If the variation was 3 degrees, west, find the deviation for the ship's head. Solution. LMT sunrise is equal to 06 hours and 22 minutes, added by longitude in time is equal to 01 hour and 53 minutes. The result is the universal time, which is equal to 08 hours and 15 minutes. Where did I get 01 hour and 53 minutes? Well, by using calculator, it is from longitude 28 degrees and 20 minutes west divided by 15. Why divide it by 15? It is because we are converting arc to time. The conversion value is 1 hour is equal to 15 degrees. Then, why add the result? It is because, in solving universal time, west longitude must be added. Using the nautical almanac, in the daily pages. Look for November 1, 2003. Under the column Universal Time, look for the day, which is 1, and locate 08 hours. Under the column Sun, look for the declination. Under the column Declination, scroll down below, until you reach, alongside the row, of 08 hours, and then you will find the declination value, which is, south 14 degrees, and 19.9 minutes. As you notice, that the declination is increasing. Finally, at the bottom left corner, you will find the D value, which is 0.8. Using the nautical almanac, in the increments and corrections table, locate 15 minutes, under the V, or D correction, locate 0.8, and then you will find 0.2 minutes. declination, at 08 hours, is equal to 14 degrees and 19.9 minutes, south. Added by the D correction, at 15 minutes, from the argument of the D value, 0.8, which is equal to 0.2 minutes. The result is the declination, which is equal to 14 degrees and 20.1 minutes, south. Why we add? It is because the declination is increasing. Solve for amplitude. The formula for solving amplitude is sin amplitude is equal to sine declination divided by cosine latitude. Distribute the value sine amplitude is equal to sine 14 degrees and 20.1 minutes south divided by cosine 36 degrees and 10 minutes north. The result is 0.30669. In your calculator, press second function, then press sine. The result is amplitude, which is equal to east 17.9 degrees south. Prefix east is from rising, and suffix south is from the declination. The azimuth, at rising, or setting, is the complement of the amplitude, so that the azimuth, on rising, is equal to 90 degrees, subtracted by the theta, at first quadrant, 90 degrees, added by the theta, at second quadrant. Azimuth, on setting, is equal to 270 degrees, subtracted by the theta, at third quadrant, 270 degrees, added by the theta, at fourth quadrant. In our example, we have an amplitude at the second quadrant, so the azimuth is equal to 90 degrees, added by 17.9 degrees. The result is 107.9 degrees, true. Solve for deviation. True bearing is equal to 107.9 degrees, subtracted by compass bearing is equal to 102 degrees. The result is the compass error, which is equal to 5.9 degrees east. The difference between true and compass is called compass error. To name the compass error. Note: if compass is best, compass error is west. If compass is least, compass error is east. Let us continue to our study. Add the variation, which is equal to 3.0 degrees west, to the compass error. The result is the deviation, which is equal to 8.9 degrees east. Note: same name, subtract, unlike name, add. To name the deviation. If compass error is equal or greater than the variation, copy the sign of the compass error. If compass error is less than the variation, reverse the sign of the variation. Thank you for watching. Please subscribe and click the notification bell, for you will be updated for our next upcoming video.